Supercontinent, a large landmass that accounts for a vast majority of Earth's land. Some researchers argue that the threshold for landmass to be considered a supercontinent is approximately 75% of Earth's continental crust, whereas others note that the supercontinent must be made up of most or all of the world's existing continents to be stable continental interiors. While supercontinents are often presented as features of past that forged the smaller continents of present, geological models suggest that the world's current continent will eventually coalesce into larger landmasses. Such processes form the basis of so-called supercontinent cycle, in which supercontinents form, break apart, and form again in new configurations. The scientific understanding of existence of past supercontinents began with the concept of continental drift, that is, the large-scale horizontal movement of continents relative to one another and to the ocean basins during one or more episodes of geological time. One of the first thinkers to consider this topic was Flemish cartographer Abraham Ortelius, who in 1596 contended that the Americas were separated from Africa and Europe by earthquakes and floods. This hypothesis was prompted by observation of corresponding coastlines of these continents, which influenced contributions by later thinkers. About 1800, German naturalist and explorer Alexander von Humboldt contended that similarities in coastlines suggest that the Americas had once been joined with Europe and Africa. And in 1850s, French scientist Antonio described the similarities between fossil plants in North America and European coal deposits. The theory of continental drift was formulated in 1912 by German meteorologist Alfred Wegener, who described the supercontinent Pangaea, a name derived from Greek word Pangaea, which means all of the earth. Pangaea was fully assembled by about 299 million to 273 million years ago, and it covered roughly one-third of Earth's surface. The supercontinent was surrounded by Panthalassa, the enormous world ocean. Wegener's ascension built upon the idea of Australian geologist Edward Suess, who had posited that existence of an enormous landmass called Gondwana land, later called Gondwana, which was made up of Africa, South America, Australia, India, and Antarctica, on the basis of rock formations in India that bore a striking resemblance to the counterparts in today's other continents of southern hemisphere. Wegener argued that Gondwana land constituted the southern portion of Pangaea. Suess has also claimed that there were at least two other continents, namely Laurentiana and Angara land, or Angara, which were located in northern hemisphere. Similarly, South African geologist Alexander Du Toit postulated the existence of supercontinent Laurasia in 1937, which was located in northern hemisphere and made up of Laurasia, a continent from which modern North America was derived. Avalonia and Baltica, two continents from which northern Europe was derived, southern Europe, and Asia, which also included the Siberian continent Angara. According to Du Toit, Pangaea was created when Laurasia collided with Gondwana land about 300 million to 200 million years ago. A number of scenarios describing the formation of supercontinents hundreds of millions of years in the future have been proposed on different grounds. One of the best known of the future supercontinent is Pangaea Ultima or Pangaea Proxima, first conceptualized by American geologist Christopher Scottis in early 1980s. Scottis envisioned a broad landmass with a large inland sea created by the closure of Atlantic and Indian Oceans. During 1990s, British geophysicist Roy Livermore conceptualized a supercontinent called Nova Pangaea, which would be created by closure of Pacific Ocean. In this scenario, the Americans would form the eastern side of landmass with Eurasia, Australia, and Antarctica in the center and Africa on the west. Another scenario developed during 1990s was predicted on the closure of Arctic Ocean, which would allow all world's continents except Antarctica to coalesce around North Pole to form Amnesia. One of the most recently conceived scenario was put forth by Portuguese marine geologist Durant in 2016 based on speculation related to the cause of Lisbon earthquake in 1755. Duarte hypothesized that Aurica, a largely circular supercontinent centered near equator, would form following the closure of Atlantic and Pacific Oceans. Forecasts by NASA have suggested that a supercontinent like Aurica would prompt a warmer tropical climate, while emergence of amnesia would lead to much cooler planet with ice sheets building up and oceans being unable to carry warm ocean currents through cooler latitudes. The existence of different supercontinents throughout the history suggests a cyclical pattern of consolidation, breakup, and reconsolidation lasting between 300 million to 500 million years. While the specific causes of supercontinent cycle remain subject to debate, most researchers agree that the process is largely driven upward and downward convection within Earth's mantle. Three models have been developed to explain the supercontinent cycle, each of which depends upon the location of subduction zones, regions in which oceanic crust at the surface is conveyed back into the mantle. In each model, a supercontinent begins by being surrounded by enormous exterior ocean, and rifting creates a new interior ocean between continental fragments. In the intervention model, an interior ocean forms and expands for a time before subduction zone develop within it, which consumes the relatively new oceanic crust and draw continental fragments back together in a novel configuration. In the extroversion model, a new interior ocean expands and the fragments drift away from one another only to collide later, possibly on the other side of the globe. The former exterior ocean contracts, most of it vanishing as a new supercontinent coalesces. In the orthoversion model, the supercontinent breaks apart and fragments are trapped within a north-south band of subduction that occurred beyond the margins of the former supercontinents. The fragments drift and later collide with one another within this band to form the next supercontinent about 1/4 of the globe away from the center of the former continent. Pangaea existed during Paleozoic and early Mesozoic era. Rodinia existed during Proterozoic era, and dinosaurs ruled the Earth during Cretaceous eon. We are living in Holocene epoch. Then, what are eons, epochs, eras? How is geological time period of Earth divided? When did the current epoch start? Let's decipher the answer for these questions in our next.